What are contradictories? Well, two propositions are contradictories when they can't both be true or false at the same time. We study contradictories on both the traditional and modern interpretation of the universal claim in categorical logic, and contradictories are fundamental to the traditional and modern square of opposition. Let's take a look. Recall that in the traditional or Aristotelian version of, or interpretation, I should say, of the universal claim, there is an assumption that at least one member of the subject class exists. This assumption allows for several immediate inferences, one of which is the inference of one proposition from its contradictory. Here are the Venn diagrams for the traditional interpretation or Aristotelian interpretation of the universal affirmative and universal negative, respectively. Now, I'm assuming that you are familiar with standard form categorical propositions. I'm also going to assume that you are familiar with the Venn diagram. The modern interpretation of the universal suspends judgment about existential import. In other words, the modern interpretation does not assume that there is at least one member of the subject class. So that severely restricts the number of inferences that can be made around the square of opposition. In fact, the only inferences that are valid on the modern interpretation of the square are contradictories. Notice the difference, as a reminder, between the traditional or Aristotelian interpretation, where a red X that's circled reveals the assumption of existential import. Here, on the modern interpretation, no such assumption is made. The Venns for particular claims, of course, are the same in both traditions. Why? Well, because particular claims already assert the existence of at least one member of the subject class. There is no assuming, it's a simple assertion. What are the contradictories? Contradictories are A and O propositions and E and I. When one is true, the other is false, and when the other is true, the one is false. So when A is true, O is false. When O is true, A is false. When E is true, I is false. When I is true, O is false. We'll look at some examples. First, though, let's go ahead and look at the square of opposition that reveals the immediate inferences, that is, the contradictories, the immediate inferences from A to O and vice versa, and E to I and vice versa, by way of our Venn diagram. Look first in the upper left corner. That is the A proposition position. Now look directly below it, the lower left-hand corner, is the I proposition position. To the immediate right of the I proposition, that is in the lower right-hand corner, is the O proposition position. And lastly, above the O proposition, that is on the upper right-hand side or in the right-hand corner, is the E proposition position. These are standard. Now, let's start with the A. When the A proposition is true, we see diagonally across that the O proposition must be false. Think about what a true O looks like, and you'll notice that we diagram the proposition as we do because we're saying that there's nowhere to put an S that is outside of P. So it cannot be the case that there is an S that is outside of P. Now take a look at the true I proposition. The true I proposition says there is at least one S that's a P. Now look diagonally across at the E proposition, and we see that if the I is true, the E can't be true. It must be false. That's because if there is at least one S that is a P, that means there is at least one thing in the overlap area of S and P. when the when the E proposition is true, that area is unavailable to anything. Right? So we've looked at true A yielding false O and true I yielding false E. Now, our other set of contradictories has a true E and a true O. Notice that when the E is true, the I diagonally across must be false. When the O is true, the A diagonally across must be false. Now, what I've shown you are the combinations of contradictories on the traditional square. Now, the modern. Notice that it doesn't matter whether we're looking at the traditional or the modern, we still have contradictories. And as a reminder, the only inferences that we make on the square of opposition on the modern interpretation is the contradictories. So, true A yields false O, true I yields false E, and lastly, true E yields a false I, true O yields a false A. Let's look at some ordinary language examples. If it's true that all dogs are animals, then it cannot be true that even one dog is not an animal. If it's true that some dogs are not chihuahuas, then it cannot be true that all dogs are chihuahuas. If it's true that no ants are whales, then it cannot be true that even one ant is a whale. And lastly, if it's true that some buildings are apartments, then it cannot be true that no buildings are apartments. Once again, we've got true A yielding a false O, true O yielding a false A true E yields a false I, and a true I yields a false E. I hope this tutorial has been helpful to you in understanding what contradictories are and how we understand them on both the traditional and the modern squares of opposition.